Hi, my name is Dr. Jude Clancy. I am the Civil Engineering Admissions Tutor for Swansea University. I'm also the Year 1 Coordinator for Civil Engineering. Basically, I keep an eye on what happens in first year just in terms of the modules that we teach and any issues with that students might have. And also I'm a senior lecturer in civil engineering as well. I'm involved in subjects in terms of urban drainage, soil mechanics, Trent materials, highway design, surveying, and so on. So our students in year one get to see plenty of me um, in their first year. What I want to do is basically go through a few things. I want to talk about civil engineering in general, just to begin with. Then I want to talk to you about the system that we have in terms of the different options, degree options that you have with us in Swansea. I'm going to go through how we teach, what we consider to be the most important aspects of what we do. And hopefully then that's going to answer most of the questions that you would have had if you were able to be with us for open days. So the first thing I want to do is just quickly talk about civil engineering in general. Some people have quite a narrow view of what civil engineering is and generally just associated with building bridges and building structures, buildings and things like that. It's a really, really complex area of engineering. It encompasses so many different areas, and you can see the main sectors of civil engineering. Transport is a very obvious one, roads, railways, and so on. Water sector is one that's growing rapidly. So for example, climate change, we have a lot more flood defense issues to deal with and try and come up with flood defense strategies for towns and cities. Coastal erosion is another huge area of research and of rapidly changing design methods and so on. Then we have things like offshore structures, a bit more of a niche area for oil platforms, ports, anything that might need anchoring to a seabed. That's all civil engineering. Energy, urban development, infrastructure, and then what we often find is that as people go through their careers, civil engineers might actually end up more in the business side or the business sector. And quite often what you'll find is the large companies throughout the world, the CEOs of those companies are actually engineers. They haven't come through business degrees and so on. So it's a massively wide-ranging area of engineering. We pretty much cover all of these areas in the degree that we do. I'll go through a few of the modules that we have and you'll see that yourself. In terms of the career itself, it is a really worthwhile career for a few different reasons. It's a lot of people want to travel. For example, when they get their graduate jobs, they might want to travel to different parts of the world. Some countries are quite difficult to get work visas for. Civil engineering is really not one of those. It's very much a required skill throughout the world, and so those difficult countries that's hard to get work visas for, generally that's not going to be a problem for civil engineers. Salaries, really good for civil engineers. It's a very creative job, which I'll talk about in a few minutes. It's never one solution to a problem. There's huge amounts of different ways you can go about trying to solve issues. A couple of other things that are really useful. It's got huge job satisfaction. There's not many careers out there where basically you are involved in the design, construction of something that can be quite huge. I mean, you can see on the screen there some, very, very large projects that as an engineer, if you were part of that, it's a great sense of pride that eventually it's built and being used. So it's a wonderful upside to the job. Another one is it's never boring. And while civil engineering is a very old profession, how we do things is basically changing very rapidly. And as you travel throughout the UK, for example, you will see smart motorways being constructed. They're a little bit in the infancy at the moment, but eventually they're going to be hugely important and they're going to be much more advanced than what they kind of are at the moment. Eventually we want cars being able to talk to roads, roads being able to talk to cars. And that technology isn't too far off. Smart cities as well. Modular buildings is something that's it's been around for a while, but it is really rapidly expanding, where basically buildings are built in factories bit by bit and then eventually just dropped in to site and pretty much bolted together. Buildings as power stations is something that again is changing in civil engineering. You know, can we build houses that actually generate their own power? Can we build office blocks that generate their own power? And as part of the open day tour that we would have, we actually have our own buildings on campus that generate their own power, and they're actually active buildings. They're generating more power than what's needed. And what those that extra power is going to is actually charging our fleet of electric cars. So if you ever get down to us, you'll be able to see that. Use of alternative materials, again, is something that's rapidly expanding, trying to get away from using what would have been considered dirty materials, steel, cement, and so on. And then self-healing materials is something that there's going to be a lot of research being done in. There is some research at the moment, but basically if you have concrete or if you have a highway that's damaged, is there a way that that material can heal itself? And there's some really fascinating ways of doing that. So that's just basically to show you that although you might think civil engineering is quite an old profession, and it is rapidly changing, and it's a really exciting time to be involved in civil engineering. In terms of what we do in Swansea, so we generally have a two-strand system, a 3-year Bachelor of Engineering BEng, 4-year Master of Engineering MEng. A little bit more complicated than that. Some students may come into foundation year on year 0. Generally, these are students who would maybe struggle with getting the required maths level that we would like to see of our students in year 1. The students who do that, it is really not a wasted year. The students who come through foundation tend to be some of the best students that we have in years 1, 2, 3, and 4. And those students would be introduced to topics such as fluid mechanics that our students who would directly come into year 1 wouldn't have seen before. So there's a slight advantage to doing the foundation year, but it's really only some students who would need to consider that. Then our BEng, MEng students, they're all mixed in together in year 1, year 2, and so on. At the end of year 2, there is an option for year in industry or a year abroad. Our MEng students tend to take that after year 3. BEng students end at the end of year 3. MEng students go to year 4, and then finally they graduate with an accredited degree. One of the questions we always get is basically if I select one of those tracks, if I want a 3-year BEng to begin with, but after a few months I would like to actually do an MEng, I would like to do a year in industry, or vice versa. Can I opt in and opt out of things? Absolutely. We're incredibly flexible. As long as grades are okay, sometimes to step into an MEng or a year in industry, we may have minimum grade requirements. It's usually around 55% average to step up to MEng or to opt into a year in industry or a year abroad. They're relatively straightforward, relatively easy to get those grades if you put the work in. But yes, it's entirely flexible to switch from one to the other. I mentioned that accredited degree. It's really important, no matter what university that you're looking at, that you make sure that you will leave that university with an accredited degree. We never have any issues with accreditation. We're constantly updating what we're doing in terms of what we're teaching and demonstrating, so that we're very much up to standard in terms of what these professional bodies require. So you can see the professional bodies there that do accredit us, so they will every few years come in and review what we do and make sure that what we're delivering is up to standard, and also that it's up to date as well. So you can see the ICE, main civil engineering body, IStructE, we have 2 highways bodies and a railway body, and basically they accredit us. Why accreditation is important is that eventually, when you have a few years work experience, your employer will be pushing you to get a chartered status. It is straightforward enough if you've got an accredited degree. Other universities do not offer accredited degrees, so just be very careful of that, and to get that chartered status becomes a lot more difficult. I could talk for hours about the modules that we do, but I'm just breaking them down into like 5 areas here. Generally the 5 areas of civil engineering. So first one will be geotechnical engineering, so designing foundations, slopes, understanding the basics of soil mechanics and how water affects strength of soils and things like that. A lot of our students, when they start going through those modules, actually develop a lot of interest in that area and would end up becoming geotechnical engineers. Fluid flow, as I mentioned, fluid mechanics is not necessarily associated by some people to be a part of civil engineering. It is absolutely a crucial area. We would devote quite a lot of our time to fluid mechanics modules. And again, in later years, what you'll actually move into is a lot more complex areas like coastal design processes and so on, where basically you will be looking at coastal erosion issues and so on, and how would you go about designing things that might prevent that or at least slow it down. Structural engineering is a massive area, obviously, of civil engineering. And you can see some of the modules there that we do. Some of them are design modules, working with different materials, working with larger structures, and then the mechanics that goes with it as well in terms of forces, moments, stresses, strains, things like that that are generated inside the materials that you use. Then what we have is what's very important. We've design modules, so these are really important. These are 3 of them. So in year 1, our students do a conceptual design module. It's been redesigned this year to be a lot more open-ended. So the problems that our students are looking at in that there's more than one solution to whatever problem it is that they're looking at. And that is true of civil engineering. If you're given specifications for something to design, then there are multiple different options about how it will look, what materials you can use, and so on. So that's a really useful module in year 1. Students take a little bit of time to get used to that, this idea of an open-ended problem, but it's a really useful skill that they'll learn in year 1. Year 2, year 3, they've got design practice modules and management modules, and these are really, really crucial. So this is where our students will be given the same documents that a general civil engineering office would have. What we tend to do is we work with the large companies, Arup, Atkins, WSP, sorry. So those type of companies, they will give us the documents that they've had to work with to design real buildings. And so our students will be working with those documents, and from time to time we'll be working with the engineers from those companies as well. So our year 3 students for the last couple of years have worked with WSP, quite a large consultancy, and they've been shown, for example, by members of that company how to use some of the softwares that they use to try and solve the designs that they're looking at. And then there's also key skills. So we do multiple other modules as well. Finite element method, which is basically really useful computational analysis system that we use, and it's very much appreciated by engineers. Not every university would go as deep into this as we do. It's one of our key areas of research. The method itself, finite elements, which was used throughout the world, was pretty much founded in Swansea University. And it's basically a case of simulating structures, forces, stresses, and things like that. So it's a wonderful piece of software and a method that we teach our students. Things like graphical design, graphical communications, obviously very important. If you're designing something, how can you communicate that design effectively in terms of drawings and cross sections and things like that. Highway engineering, obviously a massive area of civil engineering as well. Land surveying, really useful skill that our students would have at the end of year 1, and then management. So it's again, you can see a lot of these are new modules in the last 2 or 3 years. Management is really important, and it is one of the areas which traditionally has been probably ignored by many universities. We have developed this new module, which is now in year 2, and you can see there's management in year 3, and that civil engineering design practice and management 2. So we have a lot more management in our degree than we certainly used to, and that's very much appreciated by the engineering companies who our students get employment with, because the management of a job, the looking at funding and insurance and scheduling works, timing things, that's a massive part of engineering as well. And we've basically developed those modules in association with those companies, and we've used our staff who have multiple years of experience in civil engineering field as well. Just going to show you a couple of timetables very quickly. This is the year 1 timetable for semester 1 for the students we currently have. So you'll see the ones that are shaded green, they're basically any times that we have our students in the laboratories. So that's semester 1, and that's semester 2. And the reason we're showing you that is we have fantastic facilities in civil engineering We have wonderful geotechnical lab, we have structures teaching lab, fluids labs, we have multiple PC labs, heavy structures lab for doing very large scale testing, concrete labs and so on. It's very worthwhile if you can at some point getting down to us and looking at the facilities that we have. They really are absolutely fantastic. And so what we do is we try and get our students into those labs as much as possible, because doing things yourself in terms of practicals and demonstrations, it very much helps you in terms of your understanding of the theory that goes with those modules. So for example, you can see there EGA 117, that's our fluid mechanics module for year 1 civil. It's usually, for most students, a new area of mechanics that they've never been introduced to before. Some people might find it a little bit challenging, but you can see that there's plenty of time built into the year where you'll be carrying out practicals which will really help you understand what it is that we're doing in theory. So hands-on is very much a big thing for us, not just sitting in a lecture theatre. We do try and get you doing as many things as possible throughout your time with us. Just a quick word on teaching excellence. We've been rated TEF Gold, so it's a teaching excellence framework which all universities have to go through. So we've been rated gold. A couple of things there that are important just in terms of how we do things. Outstanding physical and digital resources. Again, we moved to a new campus back in 2015. We've been constantly adding to that campus since 2015 in terms of our buildings, in terms of the equipment that we have in our buildings as well. The students acquiring knowledge and skills most valued by employers. That's a really key area for us, which I'll mention in a few minutes, but we very much change what we do in our degree based on what employers are telling us are the most important skills that they are looking for in graduates, and highly personalized support for student learning as well. I'll talk about that in a few minutes in terms of academic support. Student support is important. Obviously at this current time, a lot of students are slightly concerned about what happens if I'm struggling with something. Is there support teams there to help me? We have so much support available to students, multiple different ways. All our students have an academic mentor assigned to them, so this is a lecturer, an academic member of staff, and they're assigned to a student, and they're there to basically monitor their progress, but in terms of trying to get the best out of their time there's something that we can sit down with the student and talk about in terms of how they're preparing for exams or how they're putting together reports and things like that. Is there anything that we can do to really improve their performance during our time with them? We've got a wonderful student information team, so if it's not an academic issue, but if it's a problem with illness and you can't make an exam, or if there's well-being issues, there's a fantastic team there that will sit down with you on a one-to-one basis and work through whatever issues that you have. We then have My Uni Hub, which is more for general issues in terms of funding, financial aid, tuition fees, just general advice as well. And then the Student Union have a lot of their own support systems as well, and that's a more of an independent body. Some students prefer to go through the Student Union because it's independent, and that's absolutely fine. So the Student Union replicate a lot of what we do as well. Academic support is obviously a hugely important thing. So if there is a module that you're struggling with, or a concept or theory that you're struggling with, can I get help? Again, there is multiple ways that we can give you assistance, no matter what module it is. Year 1 to year 4, foundation year, doesn't make a difference. So we have a few different ways of doing this. One way is the use of what's called support cafes. So these are rooms that we have set aside throughout the campus, and they're basically like a cafe. It's open door policy, walk in, and these are the ones that we operate at the moment. So you can see if there's a problem with writing, maths, computer engineering, science, VR, or other software. These are basically drop-in sessions, no need for an appointment. And people will sit down with you, perhaps on a one-to-one basis. It could be lecturers, it could be PhD students, it could be library staff if it's more related to certain areas. And they will work with you on a one-to-one basis, whatever problem that you have. So maths is one that people generally worry about. And you can see that Maths Cafe runs 4 days a week, 2 hours a day. So it's a wonderful chance to get extra one-to-one help in these areas. Office hours, so every subject has at least 1 hour a week where basically the lecturer, open door policy, no need for an appointment, and they're more than happy to sit down with you on a one-to-one basis and go through whatever issues that you have. Academic mentor, I've mentioned, and then there's other things like the Maths and Stats Success Program, if you need extra help with maths or statistics. And then we have something called ASP, the Academic Success Program, and these are basically workshops and small courses that you can do in your own time, just to help you. They're not necessarily credit bearing, but they're small courses that you can do to help you with certain things like PowerPoint presentations, public speaking, how to study for exams, essay writing, things like that. So plenty of help no matter what year you're in. As I said, it is a pity that we can't. I can't show you more about the facilities at the moment. But again, being a new campus, the facilities we have are absolutely fantastic. I really can't stress that enough. Our civil engineering labs are probably larger than any other discipline. I think we're certainly larger than the likes of mechanical and aero and so on. We have wonderful labs. Again, new equipment. Every year we're adding new equipment to what we have existing. So we have our concrete lab, our geomechanics, which is our soils lab, fluid mechanics. We have a fantastic set of surveying equipment. And again, we're adding to that every year. We're constantly in talks with the company that we work with in terms of surveying. They're letting us know the new forms of surveying equipment that's being used or that's coming down the line, and we're preparing our students to use those. And for example, this year we spent another £30,000 on updating our GPS handsets. So you can see that we're constantly updating what we have, making them to be up to date, and that helps to make our students more employable. We have bridge testing equipment. We have obviously steel testing equipment and tension, compression, bending, things like that. We have 3D printing laboratories, which our students quite often will use for a variety of projects. And then we've spent a lot of time in the last few years investing in our VR, AR technology as well. It's becoming much more important in engineering, including in civil engineering, where it's really useful to have the likes of VR, where you can effectively step into a building that's been designed and you can see it before it's actually being constructed. So it's a massively expanding part of all engineering, and it's something that we've invested in quite a lot. I did mention it's really important that we get you some hands-on experience during your time with us. So apart from the practical sessions that we have plenty of, we do try and get people to design, build, test things during their time with us. So you can see on the screen there's a few examples of that, quite often bridges or tower structures, or more conceptual ideas of building layouts and so on. And the idea behind this is to get you to, well, again, it's all open-ended. Every student or every group that's doing this would have their own approach to trying to solve this. So it's an open-ended problem. You get to design something, build it, fabricate it yourself. You'll learn a lot from about the importance of fabrication in that process as well. And then finally test and evaluate what went right, what went wrong, and so on. So it's from year 1 to year 3, it's a really useful process that the students go through. In year 1, to design things, it might just be doing hand calculations that we can teach you of how to analyze bridge structures. Year 2, year 3, you'll be introduced to softwares that will do a lot of that for you and will allow you to quickly make changes to a structure in the simulation, and it will update very quickly the distribution of stresses and forces and so on, and will let you very quickly see the members in that tower or in that bridge that may, for example, need reinforcement and so on. So a wonderful opportunity to get some hands-on experience. It's a good team building exercise as well from the students, because it gets them all together, looking at each other's designs, testing them. Some go well, some might go a little bit less well, but it's all about the learning of it more than anything else. What we also have is a field trip at the end of year 1. So we tend to bring our students to a venue in Wales. That venue can change from time to time, but generally it's a field trip for the students that lasts about 3.5 days. What we do there is it's all related to surveying and a little bit of highway design as well. The main reason is quite a lot of our students at the end of year 1 will be looking for work experience. quite often, if they're looking for work experience with a contractor, on-site work, what they'll be doing is they will be using surveying equipment. So this is an exercise where they're doing quite advanced land surveying, and by spending this 3 or 4 days with the equipment and quite a real life type scenario in terms of we're not necessarily teaching them, it's all about making up their own minds how they're going to do things, best approach to doing things and so on. Really useful for them as well. And what we do is we try and get down people from industry, and they'll actually demonstrate how to use and the importance of new technologies, drones, 3D scanners, things like that. I mentioned before that idea of industrial interaction and the companies that we work with. We're really lucky that because it's a new campus and because it's so big, it's been constructed by many different companies, designed by many different companies for different buildings. We've been able to get in touch and build relationships with those companies, the likes of Atkins and so on. So the very large companies that we, in the UK, we've developed this relationship with them. What they offer to us, for example, are talks, industrial talks, site visits. They give us opportunities to do research with them. So our final year students, for example, in their projects, might be working with these companies. What's also really important is that they give us guidance on what we teach. So every year we would sit down with representatives from these companies and from small to medium-sized companies in and around South Wales. They'll go through our degree, how we teach, what we teach, how we assess, and they'll give us guidance on whether that needs to be updated to take into account changing technologies and changing methods and so on. So again, I've mentioned on a couple of occasions before, we do change what we do and what we teach based on that guidance from industry. So you can see the multiple site visits, multiple industrial talks that we've had over the last couple of years. And you can see the companies, wide range of companies that have given us those site visits in the last couple of years. What we've done this year with our current year ones is that every month they've either had an industrial talk or more often a site visit aimed at them. So we've had our students in year one on multiple site visits already to different sites in and around Swansea. It's really useful for them to see new materials that are being used, to talk to practicing engineers, and they'll talk about health and safety issues and timing, programming issues in terms of difficulties on site and so on. So really, really useful talks. And again, we're trying to introduce our students to those as much as we can. I know there's plenty of information on the website about employability support. We have a fantastic employability team. Again, like all of our support teams, more than happy to sit down with you on a one-to-one basis and talk through whatever issue that you have in terms of employability. Our main aim is to make sure that you have a job, a graduate job before you leave us or very quickly after you leave us. So we invest a lot of our time into our employability team. And they'll be organising things like skills days, careers fairs, but also they're happy to sit down with you, as I said, on a one-to-one basis and talk you through preparation for interviews, assessment centres, and things like that. We have a fantastic record of employability in Swansea. Current records are that we have 97% of our civil engineering graduates in employment or further study within 6 months of leaving us. It's a fantastic record. We're rated 6th in the UK for our graduate job prospects. And again, you can see the salaries there, around 24,000 is the average salary for civil engineering graduates coming from Swansea. So what's really important is where our students get their graduate jobs. So if you actually check LinkedIn, you can very quickly see where our graduates end up getting their first graduate job or where they're currently working. And you can see that the most common companies that our students get work with are the 7 companies that you can see listed there along the right-hand side. Huge companies, multinationals, AECOM, Arup, Jacobs, WSP, and so on. So these are massive companies. That demonstrates that these very, very large organizations, very well-run organizations, value the quality of the students coming through in Swansea University. and basically that is it shows the strength of what we do, that we have these large companies really appreciating the skills that our students have by the time they leave us after 3 and 4 years. It's been a really good few years for us. So you can see plenty of awards in the last couple of years. That hasn't happened by accident. There's been a massive amount of time put aside to try and improve what we do. It's very much, all of these awards, they're not necessarily down to academic staff or technical staff or administration teams. Quite often it's down to our students as well. So we have a great partnership with our students. We have online systems where basically they can raise issues very transparently. We can reply to them and get things changed. So everything that we do, we really do work in partnership with the students to try and improve the environment around the university, to improve maybe the ways we do things, the way we assess things, and so on. So it's been a really, really good few years for us, and it's going to continue undoubtedly as we go forward. So I'm going to leave it there. It's a little bit of a shortened version, you might believe, of what I would usually talk about in an open day. So if there's any further issues, any further questions, if it's about how to gain entry into the course in terms of offers and so on, you're probably best talking to our recruitment manager, Adam Jones. You can see his details there. If it's a question about the modules that we do, assessment methods, and so on, you can see my email there at the bottom. So hopefully this was useful to you. And as I said, if there's any other questions, just please don't hesitate to get in touch. Thank you.